Okay. Welcome again. This is the webinar for the February water supply forecast. We're going to start. I kind of want to mix things up just a little bit here. As soon as my slideshow starts working. There we go. But we get a lot of comments on some of the survey questions after each webinar, and so we'd kind of like to start addressing some of those questions, and I think one way to do it is within the webinar itself. It would be nice to be able to talk a little bit about certain concepts of our model at times, certain things that people tend to be confused on more often than not. So as the situation allows, we'd like to talk a little bit about some of those things, some of the methods and some of the concepts of the model, especially if it's something that's impacting the forecasts that are currently going out as it is now. So this webinar will start with talking just a little bit about some of the components of the water supply forecast, and then I'll kind of continue on with what we typically go over, the weather last month, the current snow conditions, the water supply forecasts, and then the upcoming weather. The components of a water supply forecast, basically there's really just a few things that we have available to look at. The current soil moisture is one of those, and this particular year it's actually impacting a lot of the guidance more than it would in a typical year. The soil moisture's broken up into two components that we can look at in our model. Base flow is one. Base flow kind of represents the free water in the soil, and then there's also additional water stored within the soil that we refer to as tension water, and the tension water is directly related to the precipitation that's received within the model, and these two are really important. They're both are parameters that need to be satisfied. Any deficits in the base flow or the tension water both need to be satisfied before our model will generate surface runoff, and of course that guidance impacts the forecast, and you'll see that I think somewhat dramatically in the some of the slides that I'll show here. The current snow, of course, is one of them that we all look at as well, how well our model is simulating the snowpack that's out there, and then the future precipitation and temperature. We only have 5 days of precipitation. We frequently call that QPF, which is quantitative precipitation forecast, and we have a 10-day temperature forecast. These tend to be probably a little more influential in the spring months once we've got into the runoff season than they are now. Once we get past the first few days, we then use the 30-year climate data, 1981 through 2010, observed precipitation and temperature in generating the forecast. So let's just kind of start and take a step back to where we ended up with the soil moisture, or how we ended up with the soil moisture conditions that are currently impacting the forecast guidance. So we go back to September, which was a very, very wet month. Widespread, 200% of average across much of our area, and the map here is showing gridded precipitation. It's a little bit difficult to see the scale, but the dark, the purples are kind of in the 6 to 8 inch range for the month. Upwards in the Colorado headwaters up near the Upper Granby was actually kind of in the 10 to 14 inch range for precipitation for that month. But widespread precipitation, quite a bit in the San Juan Basin as well. And basically this all set the stage for a pretty large increase in soil moisture prior to the onset of the accumulation of snow. Next up, the slide that's going to show up here momentarily, there we go, is the modeled base flow. And again, this is kind of a representation of the free water within the soil moisture profile within the model. We have quite a bit of confidence with this particular parameter. We go back late in the fall, typically around early November, and set the flows that the model are generating to the observed flows that are actually occurring. And this tends to agree pretty well with what the USGS website shows. and areas that are kind of in the green and the blue are above average base flow, and areas that are in the orange and red are where conditions are drier and much below average base flow exists. So this was one component of the soil moisture that we have. The next one is the tension water that I mentioned, and this one is directly, again, it's directly related to the precipitation that the model receives. So, you know, there's a little bit less confidence in that. It really depends on how well we quality control precipitation on a daily basis throughout the summer and late fall. And there's a variety of reasons, whether it's a network problem, a data problem, or precipitation type that could make that somewhat challenging. We felt like we had a pretty good handle on the precipitation this fall, that it was quality controlled pretty well. So we do feel good about what this one tells us. And you know, the reason we're showing you these charts is areas that are dry or have much below average soil moisture, you know, will tend to negatively affect the runoff in the spring. It's going to affect the guidance that we're receiving today, which of course affects the forecast that you receive. The map currently would suggest that we're going to have a positive effect in the upper Colorado River Basin. The soil moisture looks pretty well in parts of the San Juan, and then fairly widespread from the Gunnison up through the Colorado, upper parts of the Colorado River into the Yampa Basin, and even parts of the Duchesne. But for the most part, as you get further west and further south, including the lower Colorado River Basin, the deficits are pretty significant, and they'll have a negative effect on the forecasts. So let's move on. So that's kind of our little soil moisture discussion, and we'd love to hear more questions, comments about this kind of approach to discuss certain components of the model with each one of these webinars. Next up is kind of a review of what happened in January. And the upper air pattern in January is depicted by this graph on the right. It's basically the contours follow the contours, and that's basically the upper air pattern where the jet stream, where the wind pattern was for most of the month. You can see along the west coast of the United States a strong ridge. It kind of kept most of the CBRFC area, the Great Basin, especially the lower Colorado, parts of the upper Colorado under a fairly dry northwesterly flow. The area where I've circled, it was an area that did get clipped by several of the storms that moved in during the month, and that area didn't do too poorly. That would include Colorado River above Cameo, the Yampa, parts of the Little Snake River headwaters that actually did pretty good in January. This next image is the January precipitation, and should show up momentarily. On the left is the map that you are used to seeing. These are kind of large areas that they're kind of showing the precipitation as a percent of average by fairly large area. They're actually the hydrologic unit code areas, and you can see on that left map the area in the Colorado River headwaters in the Yampa and Little Snake that were actually near or above average, and everywhere else was a bit drier, especially over the San Juan, lower Colorado, and points to the west. Now on the right-hand side, it's kind of a similar map. It's a little bit difficult to see, but the state boundaries are in the red. You can see the Great Salt Lake there in the blue. Hopefully that'll give you a little bit of a reference. And what we've done here, this is a gridded output of the precipitation. The scale's slightly different, but it's still very close. Areas in the green and the blue are above average, much above average in the dark blue, and areas in the orange and reds are below to well below average for the month of January. And what we've done here is we've clipped out areas below about 7,500 to 8,000 feet. About 90% of the runoff when you get into the upper Colorado Basin and the Great Basin comes from the higher elevation areas. above 7,500 feet. Much of that area below, especially as you get further south, it's kind of melted out typically by April 1st anyway. So this is intended to show more of the contributing areas. Kind of gives you a little more finer look at the layout of precip in those areas that contribute more directly to the runoff during the spring. I've got one also showing the lower Colorado River Basin, which has been extremely dry. A lot of this area received generally less than 1/4 of an inch, much of it less than 1/10 of an inch during January. Again, in this area we clipped it about 6,500 feet, but it's kind of a tough call here. You know, we're into the runoff period already, or the forecast period already, and you know, rainfall is a big contributor in this basin. So we're trying to catch the snow areas here by clipping this, but bottom line is it was just really dry over that entire area. Next, I'm going to show you the seasonal precipitation, October through January. Same kind of thing. We got the map to the left of us showing our traditional map that we're still producing. It's still on the web page, and then this one on the right that's it's somewhat of an internal tool right now, showing those areas just above about 7,500 feet. And you can see we're you know, doing okay in the upper Colorado headwaters above Cameo and the Yampa River, parts of the Little Snake, near average in some in the parts of the Gunnison, and then we start drying out as we get further into the south into the San Juan, and pretty dry conditions as we get over into parts of the Great Basin. Another take a look as well at the lower Colorado River Basin, showing you know, generally less than 50–60% of average over the entire area. Next up, we're going to take a look at the snow. I've got a side-by-side comparison. These are the SNOTEL sites. There's a scale at the bottom. This is represented in percent of the historical median. You can see the January 6th snow on the left, the February 5th on the right. It's kind of a tale of two cities when you look at the snow. The Great Basin, things are really in a sad state of affairs. Generally, you know, many areas are less than 75% of the historical median, matches the historical average pretty close this time of year. And some sites even below 50%. Not a lot of change. It was fairly dry. We did actually see a little bit of snow melt in southwest Utah and the Virgin River, so those areas have dropped even further. As you get into the San Juan Basin, you know, we did see a decrease in the snow due to the dry, but the soil moistures kind of maintain the forecast in that area. And then you get up into the areas of kind of the northeast Gunnison, the Colorado River headwaters, again above Cameo, and up into parts of the Yampa Basin and the Little Snake, and we've actually seen some improvement there. You know, there was a good improvement also at the very end of the month. We had a storm system come in right around the end of January, 1st of February, and hit that northern area pretty good once again. So that area had, you know, at least benefited from a few storms that were moving through during the month. One discrepancy here, that if you can recall the precipitation map that I showed a moment ago for the seasonal precipitation in the upper Colorado and Yampa, they were kind of closer to average, maybe 110, maybe 115% of average, yet the snow is up around 150%. So that kind of begs the question, you know, why is that? You've only had average or a little better than average seasonal, but you've got really good snow conditions up in those areas. Well, one of the reasons was we really started accumulating snow at some of those high elevation sites a little bit earlier than we usually do. The map here on the right is the October temperature departure from average. This is for the maximum monthly temperature. The whole area was quite a bit cooler than average, except for extreme, you know, southern Arizona. You look up north, we were on average 1, 2, 3, 4, 5 degrees below the average for the month. So we had some cold storms that came in. On the lower left is the Copper Mountain SNOTEL. The green line is this year's snow accumulation, and the blue line and the purple lines are the average and median. The red line is last year. So you can see that, compared to where we typically are early on in October and November, we had started accumulating snow a bit earlier. So some of that typically falls as rain that time of year actually fell as snow. So that kind of gave us a boost in the accumulation of snow. Next up, I will show some of the snow groups that you're accustomed to looking at. We'll start with, well, first of all of these areas here, again, the Upper Colorado region did better than 2013, or we're doing better than 2013. Again, last year is in the red, the green is this year, and the average, the purple, and the median. I'm sorry, the average is the median, and the blue is the purple. No, I'm sorry. The average is the blue, and the median is the purple. There we go. Too many colors for me, guys. So anyway, if you take a look at this, you can see the upper green pretty close to where it typically is this time of year. The Upper Colorado River main stem, and again, this is above Cameo, doing a bit better. So you can see that last storm at the end of the month there, at the end of January, that boosted that up quite a bit. And then we're near average, a little bit better in some parts of the Gunnison than others, but the basin as a whole is doing pretty close to average, and just a little bit below average in the San Juan Basin, somewhat similar to last year. And again, the reason the forecasts are a little bit higher is primarily due to the soil moisture. As you move west and south in our area, you get into the worse than 2013. Moving over into the Duchesne, definitely not doing as well as the rest of the Upper Colorado River region. The Weber River drainage in the Great Basin doing a little bit worse than 2013. Pretty sad in the Sevier, the Virgin, and across Arizona in the Lower Colorado River region. So we just haven't seen the storms in these areas. Been dominated by that high pressure more, and you can pretty much see the dismal effect it's had on the snowpack. So that's kind of where we are as far as entering into developing our water supply forecasts. We've got the soil moisture situation, we've got the precipitation situation, and then we've got the current snow. We'll get into the future weather here in a minute, but that's kind of where we are when we're making our forecasts for February 1st. And this is a little bit different graph. I'm getting a little bit away from showing all the individual plots, and if I'm going to show a couple, but the evolution plots, they're all available on a web page, but I thought it might be more, I don't know, maybe a little bit more informative to show you this spatially and show you the distribution of the forecasts and how they compare with one another. And I've listed on here some of the main points, some of the larger reservoir points, and some of the main points that many people tend to focus on. And you can see that we're still looking pretty good in the Yampa, the Upper Colorado, and even parts of the Upper Gunnison. Those areas all increased over last month. Blue Mesa increase was over 90,000 acre feet. When you get down into the San Juan, a little bit, the forecasts still look reasonable. They did decrease a little bit from the January 1st numbers, but again, that late end of the month storm, as well as the soil moisture, the guidance continues to indicate not horrible conditions there. Things would definitely change, though, if we do get into a real dry pattern between now and the runoff on April 1st. Lake Powell right now is at 7.25 million acre feet. It was 95% of average on January 1st, and now we're forecasting 101% of average. As you get further into the Great Basin, though, you can see where it gets pretty dismal. Many of the areas are below 70%. A few of them are actually below 40% of average. So not not looking very promising right now in the Great Basin. This next map that will show up here momentarily is going to show you basically the forecast trend between January 1st and February 1st. Sorry, I'm having a little delay in this coming up. There we go. And so the areas in the pretty much in the blues are areas that increased. The green didn't really change much, very insignificant. Actually, the yellows are fairly insignificant changes too, maybe just a very minor decrease. But basically, you can see where the storms came across that eastern part of our basin, affecting the upper Colorado, Yampa, Gunnison, and those areas actually showed a little bit of improvement. Lake Powell, of course, improves because all of those areas are draining down into Lake Powell. So there's reason for a little optimism there, I guess. San Juan River Basin decreased a little bit, as you can see, and then the Great Basin decreased more than anyone else. And this decrease is basically the change in the forecast as a percent of average between January 1st and February 1st. I have a little one also showing the lower Colorado River Basin. The lower Colorado River Basin is a February through May forecast volume, and it's just been bone dry in Arizona. The forecasts are very, very low. And as we get further into March and April, we really start getting into the drier time of year. So it just becomes, unless there's some very large precip event, less likely we're going to make this up in this area. The next slide, these are the plots that I was referring to. And for those of you who've not seen these, they're basically a daily forecast for the runoff. And this one is for example, Lake Powell for the April-July period. These are all available on our website. We typically bounce through a whole bunch of these. I kind of wanted to show the forecast more spatially in those previous maps. So please comment afterwards if you don't like those old maps and you prefer to see these or you prefer to see both. I just think it's a little more informative looking at things kind of spatially like we were. But it's always worth, I think, highlighting a couple of these when the condition warrants. They are available on a web page. It shows once again what they are. The forecast distribution from our ensemble prediction model, or ensemble streamflow prediction model, which is ESP for short, and our official forecast that's issued at the first of the month. The ESP forecast, the ESP guidance that comes out, raw guidance, that solid blue dot in the middle is the 50% exceedance value. On the top, very top of the bar is the 10%. On the bottom is the 90. And then where those color changes occur kind of in the middle is the 30% and the 70% exceedance forecast. So you can kind of see over the course of time how this changes. You can follow it after storms. And one thing I think that's interesting is, it drops and then it increases and it drops. And so it can be quite variable after storms. You go through these periods of wet, you go through these periods of dry. It's kind of up to the forecaster when they make the official forecast to interpret exactly what that means and maybe kind of smooth things out a little bit when they're making the final forecast. That final official forecast is in the red. The 50% is right in the middle, the red dot, and then the bounds, the 10 and 90%, are on the top and bottom respectively. And then there's also the official forecast is actually specified up at the top of it. For instance, this is Powell. There's the 7.25 million acre feet, 101% of average. And at the bottom, it kind of shows you the change from day to day. So this, again, is available through our website for all of the various points. When you go into our website and you click on water supply, you get this map. And these are, again, also another way of looking at the latest forecasts that were issued. This is the official forecast as a percent of average throughout our basin. You can click on any of these triangles to get to your particular area of interest. Again, this is, for instance, this is the Vallecito Reservoir inflow. And I kind of wanted to throw out this one because it was interesting what was going on here while we were making the forecast. We were actually having a fairly decent precipitation event. This happened both in the San Juan Basin and the Gunnison Basin. And right in the middle of this, we have to make a forecast. So this lower black arrow is showing the ESP guidance that we pretty much had to look at the time when we were making our forecast. And then after the weekend of February 1st and 2nd, where a lot of the precipitation fell, you can see the ESP, the raw model guidance, had jumped up quite a bit. As forecasters, we do have insight to this. We try and make adjustments for this. It's always kind of a challenge when you're getting a big event right when you're trying to make a forecast. But we do account for that, and I just wanted to kind of point that out. In this case, we went a little bit above the ESP guidance that we had on the 31st of January, and by February 2nd, it was higher, and we're kind of in the middle. So that was another reason we tended to keep those forecasts up a little bit, because we knew we were getting precipitation in the area, and we had precip forecasts to actually look at. This next slide is just a quick indication of that was the precipitation that occurred between the 31st of January and the 2nd or 3rd of February. So, and you can see we had anywhere from a half inch upwards to a couple inches in the Gunnison and parts of the upper San Juan. So that's again always a challenge when that's occurring right when you're making a forecast. So let's jump into the future weather, and then I will open this up for questions. So the weather pattern has changed. In January, again, we had that ridge over us. I tried to depict kind of the storm track as best I could with those black arrows on each chart. And we've moved into what's considered a zonal flow, where we're more of an east to west pattern. Storms are moving in fairly quickly off the Pacific. This tends to bring in a little bit more moderate air mass, a little warmer air mass, which means it's also a little more moist air mass, and that's definitely a better thing. There's more opportunity to see precipitation events in the area, over our area, when we're in this kind of a pattern, and it looks like we're going to at least push or remain in this pattern, probably through the middle of the month. I've got next up just showing some of the precipitation forecast over the next 5 days. This is actually what's going into our model. Again, I apologize, the quality of the graphics aren't perfect, but this is an internal tool we use to analyze the precipitation forecast and make adjustments to it. So you can kind of see the state outlines there in the dark blue are the rivers, the main rivers. And I've got areas, those arrows point to kind of the Upper Green River Basin, the Northern Bear River Basin, and also kind of the Little Snake extreme Upper Yampa Basin. Over the next 5 days, we may see 2 to 3.5 inches of precipitation. Those would kind of be the maximum amounts over these areas. That's at least what we're putting in our model right now. But precipitation has returned to the area, and that's at least a positive thing. It's probably going to be focused a little bit more in the northern areas than it is, from, I would say, the Upper Colorado River on down. Taking a look also at the precipitation probabilities. This is from the Climate Prediction Center. Into the middle to third week of the month. It's kind of the same pattern. It shows the best chances for above average precipitation are going to be the extreme northern part of our basin. So once again, parts of the Upper Green, Northern Bear River Basin, perhaps parts of the Weaver River Basin. And as you get further south, then we get into less of a chance. So, and that unfortunately pushes in to include, at least in the middle part of the month, the San Juan Basin, the Colorado, the Upper Yampa, the Colorado River headwaters are kind of in really not a strong signal either way. But as you get further south and into the lower Colorado region, right now, at least the way the flow shows, it's not all that favorable for getting a ton of precipitation in that area. The long-term precipitation outlook that we put on here from the Climate Prediction Center, there we go, shows the outlook for February and then also the outlook for February through March. And this outlook in February was, actually this was made at the end of the month, and you can see it doesn't really show a whole lot. Equal chances throughout most of the upper Colorado River Basin on both of these. Not a great outlook for the lower Colorado River Basin now. It shows increased chances of below average precipitation throughout Arizona. But areas outside of that, there's not a lot of skill. So we'll just kind of have to wait and see. And because you know, and this is one of the reasons we tend to use our historical climate that we've, you know, from our calibration period in the model. Again, it's 1981 through 2001. So after the first few days in our model, we just run with historical climate to come up with the guidance values. So in summary, the soil moisture impacts that you saw, we have base flow conditions and we have attention water parameter in the model that both must be satisfied before we start generating surface runoff, before the model starts generating that, and that of course affects the guidance, which affects our forecast. Right now this is showing a positive effect in much of the upper Colorado River Basin from the San Juan north pretty much, and a negative effect in the Great Basin and the lower Colorado, which actually brings those the guidance down. The snow, two vastly different situations. If you saw, we're looking, you know, fairly promising right now from the Yampa throughout the Colorado River headwaters above Cameo and down into the upper Gunnison Basin. Not horrible in the San Juan, but definitely something that we hope we don't go dry in that area. And then once you get west and south of that area from the Duchesne River Basin through the Great Basin down into lower Colorado, it's fairly dismal. The forecasts I've kind of summarized there with the areas above average or where the snow is good and the water supply is good. San Juan near to slightly below. Again, the soil moisture conditions are what's really holding that basin up right now, I believe. And then when you get into the Great Basin, Duchesne, Virgin, and areas west, you know, again, it's dismal. The weather, the pattern's more favorable. I mean, I know the precipitation is right now we're indicating it's going to be focused more on the north. But one thing about a zonal flow, storms move in fairly quickly. I don't think the weather models handle them all that well sometimes. You know, if you get any kind of buckle in the jet stream, it could easily send something further south into our area and generate some precipitation. So, you know, at least there's not a ridge of high pressure over us. This I would consider a more favorable pattern that will at least open the door potentially for some storms to move in during at least through the middle, maybe even the third week of February. And still there's no strong climate signal. I didn't focus a lot on the El Nino on this one because it's still neutral and it's forecast to continue neutral into the summer months. Beyond that, there's not really a strong indication. Maybe neutral, maybe going El Nino, but for our purposes for this year, it's not really suggesting you know, anything that's going to affect us as far as the runoff goes. So let me two more things, and then we'll open this for questions. Just a reminder, our forecast webinar schedule for the next ones, March, April, May, June. These are the times, and there's the link or the location you can register at these. We are also having our stakeholder meeting in just under 3.5 weeks on February 25th and 26th in our office here. This is attainable through our webpage, or please call me and we can talk about the content that we're going to. There is a link to the agenda on the bottom of this page, so you can find that through our webpage. We'd love to have you come. It's a great opportunity if you can make it to ask questions, learn a little bit more about some of the details of our model, and we're going to forecast a lot on our products and services and interpretation of our products as well. We kind of like to make these somewhat interactive workshops, so we can learn as much from you as you learn from us. Again, the offer to please contact us with any specific questions, especially forecasts in your basin that you want more information on. These are the list of forecasters and the rest of the staff, and you're more than welcome to talk to us about that. So I'm going to unmute this.
The conference is now in talk mode.
And I'm going to check some of the written questions. Does anybody, okay, let's see here. Let me look at the webinar questions really quick and see if I can make these show up. Well, while I'm trying to do this, does anybody have any questions they'd like to ask?
Yes, Greg. This is Ken Curtis Dolores. You mentioned on the base flow component of your soil moisture that you calibrated or corrected on November 1st. And I guess I wanted to make sure I understood that correctly and ask if you did that at other times in the year.
You want to answer that?
Yeah, I'll answer that. Yeah. Is it on?
Yeah.
The answer would be, yeah, we adjust to the USGS flows during high and low conditions all the time. But towards the end of the year, typically around November 1st, before all the gauges freeze up, we make a big effort to make sure that we have all the base flows pretty much identical to the USGS flows and or the inflows into the reservoirs. So yeah, it's kind of something we do on a daily basis.
Okay, thank you.
I also have a question online. Raphael, I think you asked this about, I don't understand the question.
They termed that ridging that we had in January is a ridiculously resilient ridge. And I've seen it on the papers several times anyway. And obviously, you pointed out that in February it's basically dissipated or gone away, and you've gone to a zonal pattern, as you put it. And I was kind of curious: is there what you got any sense as to whether or not this thing might return?
I mean, it's always possible. You know, it's not typically what we really see in the spring months. You know, the zonal flow that we get is a little more of a typical spring pattern. You know, that tends to occur quite a bit really in March, you know. But I honestly don't. I mean, it's possible. I know what you're talking about, and I've read the articles too, how it's just been fairly persistent out there for many months, and it's just depending on where it's shifting. But you know, from at least our analysis, I mean, it's kind of out of the picture right now. So I wouldn't. You know, anyone's guess, but I mean, I don't see anything indicating that it's going to come right back and park itself over us for a long time.
Cool. So, that's good news. Thank you.
Yeah, hopefully. Yeah, that's a low confidence forecast, by the way. But yeah, I mean, there's nothing indicating it right now at this time. So.
May I ask another question?
Yes, please.
Regarding the ESPs, I forget how much of your weather forecast is part of that forecast.
Well, what we feed into our model each day is five days of precipitation forecast into the future. So 5 days of future precipitation forecast, and we also feed into 10 days of temperature forecast. So, and you know, if you go look at those plots on our webpage, you know, I think it defaults to just the I mean, we have two options. You can look at them without a future precipitation forecast and with one. You know, and we tend to like to default to the one that doesn't have it, just because this time of year especially, you know, you get into a wet period and ESP may go up a little bit and then it dries out and it kind of comes down a little bit, so it tends to balance it out. I think it's probably may have more of an impact, you know, once we start getting into the runoff period, because that's going to come right off, you know, at that time. A lot of times it's also rain events. So, but just to answer your question, 5 days of precip and 10 days of temperature.
Thank you.
Any other questions? Okay. I guess if you still have questions after we're done, you're more than welcome to give us a call or drop us an email. I'm going to make